Here we have the quadratic formula, and the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's a handy formula that you should have pretty much memorized, because we use it sometimes all the time throughout future math classes. You've learned it in previous math classes. You can solve any quadratic equation, any quadratic in nature equation using the quadratic formula. It's just not as easy. It's not always as efficient as maybe factoring when factoring is an option. So I'm going to show you on this first example. This first example, if you can factor, we're going to get 2x, x, and then we're going to say positive 1, negative 3 equals 0. And we already know our answers. X equals 3 and x equals negative 1/2. I think we've got that right. Yep, we've got that right. So we already know the answer to this. It's positive 3 and negative 1/2. However, if we're told to solve this using the quadratic formula, I'll show you how we can still get the answer. We know it's going to be 3 and negative 1/2. We can still get that answer. It's just a little bit more work. Now, sometimes you have to do this work because you can't factor. Sometimes the trinomial is just not factorable. So when it's not factorable, we go to the quadratic formula. So I'm going to show you on this one some numbers that we're familiar with. X equals the opposite of b plus or minus the square root of b squared. Now that b squared is highlighted in blue up above in the formula because that b squared, that term will always be positive, minus 4ac. And that's all over 2 times a, which is 4. 2 times 2 is 4. X equals 5 plus or minus the square root of 25. We're going to have a positive because a negative times a negative is a positive. And then 8 times 3 is 24. And 25 plus 24 is 49. And the square root of 49 is 7. So 5 plus or minus 7 all over 4. That's going to give us x equals 12. We've got 5 plus 7 over 4. 12 over 4, which is 3. And then we have, let's make some room here. Move that up just a little bit. And we'll move this up just a little bit. And now we have x equals 5 minus 7 over 4, negative 2/4, which is indeed negative 1/2, which is exactly what we said the two answers were by factoring. But you can see that I've put in a little bit more energy to get the answer using the quadratic formula than I probably needed to if I was able to factor. Now this next example, not able to factor this next one. So this next one, we're going to solve using, again, the quadratic formula. So x equals, we'll write a equals 3, b equals negative 12, and c equals negative 7. Now, if you weren't sure where that was coming from, hopefully you saw that written down right here. We write it in blue. It comes from ax squared plus bx plus c equals 0. That's where the a, b, and c are coming from. So x equals the opposite of b plus or minus the square root of b squared, which is 144, minus 4ac, all over 2a, which is 2 times 3, which is 6. So 12 plus or minus the square root of 144, again, we'll have a positive. A negative times a negative is a positive. 12 times 7 is 84. That's all over 6. 12 plus or minus the square root of 144 plus 84 is 228. 228 is going to break down. 2 goes in there 57 times. And then we have a 3 and a 19. So we've got a pair of 2's 12 plus or minus 2 times the square root of 57 all over 6. And our last step is to look at these three numbers. Your number out front before the plus or minus, the number in front of the radical, and the denominator. And if all three of those numbers share the same factor, we need to reduce. So they all share a factor of 2. So we divide each term by 2, and we get our final answer, x equals 6 plus or minus the square root of 57 all over 3.